Hello everyone, in this video we'll be solving a easy problem number 9, palindrome number. The problem statement is given an integer x, return true if it is a palindrome or else return false. In example number 1, where x is equals to 121, as the number is a palindrome, the output is true. But in example number 2, where the number is negative 121, it is not a palindrome. If we reverse the number, it will be 121 and with a minus sign or a negative sign which is not equal to the original input, hence the output is false. There are multiple approaches to solve the problem. The most simplest and the easier way is to convert the entire number into string, then reverse the string and then compare it with the original value. If the values are equal after reversing, it is a palindrome and we can return true. If we were to take this approach, our time complexity will be O of n, where n is the number of characters in the given number, and the space complexity will also be O of n, as we are creating this reversed order variable and then comparing it against the original string. Although this approach solves the problem, there is one another way which we can use where we don't need to convert the given input into the string format. We can use the number as is to check if it is a palindrome or not and accordingly return true or false. So let's switch to whiteboard and discuss that approach. One way to verify if a particular number is a palindrome or not is to divide the entire number by half, that is divide it based on the number of digits, and then compare the first half with the second half after reversing it. In a palindrome number, the first half of a number is always equal to the reversed version of the second half. If we apply this logic to the given input, the first half is 12 and the second half is 21. Now if we reverse the second half, it will become 12, which is equal to the first half. Hence the number is palindrome. Let's try a different number, that is 1, 2, 2, 3. Applying the same logic, first half is 12, second half is 23, the reversed version is 32, which is not equal to the first half, hence the output is false. This logic is straightforward when there are even number of digits. What if there are odd number of digits in the input? Let's cover that scenario too with this input 1, 2, 3, 2, 1. Now if we were to calculate the midpoint of this number, it is 3. Now to look at the first half, we could include 3 in the first half or we can exclude it. If we are including it, then it has to be included in the second half as well, or if we want to exclude it, we need to do the same on both. Let's say we exclude it. So the first half is 12, second half is 21. Reversing that will give me 12, which is equal to the first half, hence the number is palindrome. And if we were to include it in both the sides, the first half will be 123, the second half will be 321. Reversing that will give me 123 on the right hand side, which is equal to the first half, hence the number is still palindrome. I hope you are able to understand how we broke this problem down into smaller pieces and compare the first half with the second half to check if the number is palindrome without having to convert the integer into string format. With this solution, the time complexity is O of log n to the base 10, where n is the size or the number of digits in the number. This is because we are breaking down the number into halves and then processing them. Hence the time complexity is not O of n and instead it's O of log n. And the space complexity is O of 1 as we are only using one additional variable to record the reversed version of the second half of the number. Let me show you how we can implement this using C#. Here is the C# solution. In the main method, I start by adding a couple of validation to make sure that the value is in the valid range. After that, I am initializing this reversed half variable which is set to 0 and then running the while loop which will help me build the reverse half of the original number. I am using the mod operation to get the units place from x and multiplying it by 10 as we continue the loop further. At the same time, I am also dividing x by 10 to remove the last units place from it so that we can get the first half of the number. Once the while condition is broken, we jump out of the loop and check if x is equal to reverse half. This is to cover the case when there are even number of digits, and if there are odd number of digits, we divide the reverse half by 10 and compare it with x. and based on the comparison, we will either return true or false. This code, when submitted on LeetCode, beats nearly 78% of the submissions in terms of runtime and 77% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.